Hey guys, welcome back to the channel. So today we are solving the next question of the linked list series. So it's question number 19 on lead code, and name is remove and node from the end of list is actually the we have seen, how to make a linked list, how to insert in the similarly deleting from the linked list is one of the good question sometimes you find in the interviews. So you have given the head of the linked list, you have to remove the nth node from the end of the list and return its head. So what actually the question is saying, like is saying like you have a linked list like that, 1 2 3, and you have given n equals to like 1. So you have to remove the nth node from the end side. So from the end side the first node is 3 1, so you have to remove the 3. So after removing, what will it be become 1 and 2 because you remove the 3. Okay, if 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 n equals to 2 is there, you have to delete the second node from the start. So first node is 3, second node is 2, you have to remove 2. So after removing 2, the linked list should be become like 1 is 3 because you have to delete the second node, and second node is 2 from the end. So how you approach this question is one of the good things you have to think of, like simply things in the linked list. You don't have a single linked list, you don't have a pointer to previous pointer, so you cannot go to the last and come back, delete the node and come to back, because you have to, if you delete that particular node from the linked list, you must link the previous node of the linked list to the next node of that later linked list. So if you are removing 2, you have to link 1 with the 3 before deleting, so to connectivity of the linked list remains same. Okay, and in the single list you don't have the previous pointer, so if you delete 2, you don't have the previous pointer of 1. So how you approach this question? Okay, so you do not go to the if there is a something like previous pointer, something like here you have put to the last and just array I minus 1, you can do in array I minus 1, you link to I plus 2 in simply if you think of an array, but it's not array, you have to think similarly, it's like an array but it's have the linking part, so you cannot go from the last, so you have to think something to get. If you have to delete that particular node, like if you have to delete the second node, you have to come at 1, and from the 1, if you had at 1, the next pointer is the deleted node, and so you just put a value of that particular node in a list node, that will store the value which you have to delete it. Like you come at 1, you have to delete 2, so store 2 at something and link 1 with the 3 by 1 next connects to 1 next 2 equals to 1 next time, because is 1 and 1 next is 2 and 1 next connects is 3, so you have to link 1 connects equals to 1 connects connects before deleting. But store that to have to and just link, so you do not delete from that, you have to just come over. So if you are given the like n equals to 2, so what do you think, assume from the explanation that from like deleting the second node, you have total actually 3 nodes, and you have to leave the second node, just count 1 to 3 nodes, so 3 minus to 3 minus to 3 minus 2 is actually 1. So you just from 1 you can add 1, and the second node you have to delete. So this is how, like similarly 1 2 3 4, and if you have n equals to equals to 3, so it will delete the third node from the last. So third node is 1 2 3, it's 2. So and total node is 4, total node is to 4. So n total minus n, if you store like something total minus n, to what it's give, it's give you, if total is 4, total minus n, 4 minus 3 is give you 1. So it actually give you the current node, the node which after which is that you have to delete. So p gives you the value of that node up for after that node what you have to delete. Okay, so you have to think of that. So yeah, we know that p gives you the value after which you have to delete the node. P gives actually the node, that node, that deleted node previous value. Okay, so because if we have that p, so we easily can delete the next node, and after that we link that. So that means we have to just, we have that n node, we have to count the number of nodes and store like the total nodes minus n, so we gives us deleted node by p plus 1 is the actually we node we have to delete. So we are just think the logic. Yes, we know that p plus 1 is the latent, we have to delete the p plus 1 node. So if we have, when we reach at the p node, first we have to reach at the p node. It's not always that at the starting, no. Like here's something, it's 2 3 5 6. Okay, their total node is 4 here, total equals to 4 here, and maybe n equals to 2, n equals to 2 there. So your p equals to here, total minus 2 is n minus 2. So second node, actually you have add the second node and you have to delete the 5 node. So you have to first come to the p value. So p value actually starting, p value from the starting you have to come to delete the p plus 1 node. So we have to come for p1, p2 is 3 here. So when we come to 3, just have to delete p plus 1 and link first, before deleting link 3 to 6 before deleting 5. Okay, so that's is the how you have to think. First you have to count the total number of nodes, just count the value of p and just reached at the p, then you have just a simply logic of p plus 1 delete and link to that. That's only you have to solve it, nothing to add in extra. Yes, there is a best case if, like, if there is a condition, if there, like when you count the p, if minus there is only one node or actually two node and total node is also two node, so it's 2 minus 2 0, 1 minus 1 0, you have to delete the that node as the first node of the linked list, because 0 is the first linked list. So just store the next and delete the head and return head next. Simply you have to check before doing that extra things. Okay, so yeah, so how we approach now solve the question. It's actually, I said that we have n already. We have first count the nodes, so make a count variable equals to 0 and make a temp. It's a good practice to make do the operations in the temporary nodes, not in the original node, because it can be used in many extra things also. So just here for the count logic with the while loop or for loop, while temp not equals to null. Okay, temp not equals to null, just count plus plus and temp equals to temp next. This is how you have to count. So it's 1 2 3 4 5. Now I say store it of value in any variable p I just made, and total nodes is our count minus n. Now check if p equals to 0, it means you have to delete the first node. If p equals to 0, you have to just delete nodes. So first store the next node in someone else. Okay, head next, you can say head next, and store actually the head next value before deleting head. Before deleting you have to store the links all. Okay, so now delete. For deleting it, simply delete head and just return here, return head next. Okay, now if this is okay, if this is a NOS case, you have to first reach to the p node. First make a count variable until you have to reach that p value. So while before c, we are studying head is our first node, we know. So also make a temporary node as, let's say, good practice. It's not a very, but yeah, it's good way if you can do like that. Okay, then equals to head, we are at the first node, while c less than p and n. Also temp not equals to null. Okay, yes, maybe sometime, so you have to check that. So just do what you have to do. Temp equals to temp next to done, and count increases, count plus plus until it reaches p. So just how, like we have to delete in this case n equals to 2 and total 5 minus 2 is 3. We have to reach the third node, 1 to third node. So count is initially 1 and p have to reach 3. To count equals to 1, then we just next count is 2, then we just count is 3. Now count is 3 is not less than cp, so we are just break down from there and we are at the third node. So we are at third node, value third node, so we have to delete 3 plus 1, actually fourth node. So how it delete? Simply make always a link to delete. For deleting, make a delete node, this node which you have to delete. Okay, but you delete node. But you have to delete node. In delete node we have temp next. Temp next is the node we have to delete, and for deleting just link that temp with the temp delete node next. Okay, temp next equals to, actually what is the temp next? Temp next equals to temp next. Temp is this third value third node. Temp next is 4, temp next is 5, so I have to temp connects to the temp connects. Okay, simply nothing to worry, think of much, just do it. Just do it and just delete, just delete, but we have to delete node and just return head, just run it. What's the error in this? Okay, it's not start, it's end actually. And also it's there in the what's the error we have to see. Actually redefinition we actually have to also. Okay, so no need to, just we have already declared temp, and that's why re-declaring is not allowed. If you have to redeclare, just delete it or just use it again. Yes, we have submitted the solution, and it's a very pretty easy solution. Mostly the complexity in deleting is if it is like n node, so it's order of n, so it depends on the things. Okay, it's good problems, you can see it, not an very hard problem. And this way other type of problem you can see, it's like deleting the middle nodes. You know how you delete middle node, you know how come we know to find the middle element. So when you know the with the slow and tortoise or anything, you know the middle element, you reach the middle element, just remove it. Can be the first middle node in this case or second, you according to this you have to find that middle node. Okay, and just link, similarly you have to link then again. That's how we in the last things we have done. And similarly leading middle nodes is similarly like that, best we have to find middle nodes where it's just counting. Just that's the different deleting problem is can be done. Okay, or the question similarly if I delete the node from the starting, it's also simple. It's likely similarly like we do not have to just only just have to do simply these things. So by this way we have done this. Thank you guys for watching. Bye bye.